Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Students, today we'll discuss about question number 28 of JEE Advanced Physics paper 2015. So let us start with question number 28. Hello students, let us start with question number 28 of 2015 JEE Advanced Physics paper. A large spherical mass M is fixed. This mass is fixed at one position, so it is fixed here, and two identical point masses M are kept on a line. So these are the 2 point masses kept on the line passing through the center of M. Through the center of M there is a line drawn like that. So these two masses are placed on this line. The point masses are connected by a rigid massless rod. So these two are connected by a massless rod of length L, and this assembly is free to move. So this is free to move along the line connecting them. So this can move this direction or this can move this direction. All three masses interact only through their mutual gravitational interactions. So that means only gravitational force of attraction between these three are there, and no other masses will be, or force due to other masses will be considered. Only these three masses will be considered for gravitational interactions. When the point mass nearer to M, when the point mass nearer to M is at a distance r, which is given as 3L from M, the tension in the rod is 0 for M equals to this. So what value of M, what should be the value of M for which the rod will have 0 tension? Tension in the rod is 0. The value of K is how much? So to find this value of K, to find this K. Now we have this is the center of this bigger mass M. Point mass is placed here, another point mass is placed here. This is small m, this is small m, equal point masses. This distance from center is r, and this distance is L. This is connected by a rod. This is a rod. This is a rod which having length L, and this R is given as 3L. So from here to this point the distance is 3L. From here to the other point mass M, this distance is 4L, because this is 3L plus L is 4L. And between these two masses the distance will be taken as L, and this is a rod, and the tension will be developed only when one is so the tension has to be 0. So we must understand that if a rod is having two masses at its ends, then this rod will have tension if this moves. So that is the relative forces or the relative accelerations between these two masses. That means, suppose that this mass is moving in this direction and this mass is moving in that direction, and and if one is having higher acceleration than the other one, then one wants to move faster relative to other, so there will be a tension then in the rod. If this mass and this mass, both the masses will move, suppose in one direction, suppose like this, and it is moving with 2 meters per second square, and this also moves with 2 meters per second square in this direction, then the rod will not have any tension because both are moving with the same acceleration. That means the acceleration on this mass and this mass must be same. That means the net force on this mass and this mass must be same. So we have to find the net mass on this mass, net force on this mass, and net force on this mass. And we will equate and we will equate those two net forces and then solve for the small m. As we solve for this small m, we'll get expression of this form with some number out here, and that number must be k. So now what is the net force on this one? Suppose I call this F1, net force on this one, and net force on this one I call F2. So F1 and F2 are the net forces on the masses, first mass and second mass. Obviously having masses small m, then we'll then equate those two masses. So must be same. So to have no tension or zero tension, where both the masses, net force on both the masses should be same. What is the net force on the first mass? We have called it F1. And what is that F1? That F1 must be equal to, this mass is subjected to two forces. This mass will exert a force in this direction towards right, and this mass will exert a force towards left on this mass. So this due to the bigger mass, the force will be, according to Newton's law of gravitation, this is G, capital G, product of these two masses divided by square of this distance, which is 3L square, that is 9L square. So this is G, capital M, small m, divided by 3L square. This force is towards right and due to the small mass m, this force is on this mass is towards left and therefore negative. So minus, because this force is towards left, this is G. Because of these two smaller masses, this is m square divided by distance is L, so it is L square. Similarly, the force on the second mass, that is F2, net force, is because of this bigger mass, this will be, force will be in the right direction, and because of this, this also will be in the right direction. So in this case, both the forces will add up. Because of bigger mass, the distance is 4L. Because of smaller mass, the distance is L. So we'll have G, because of bigger mass, 4L square, plus, because this is towards right, and because of the smaller mass also, the force is towards right, so it is G of small m square divided by L square. This is also towards right, therefore this is positive. Now these two forces must be same. If I equate those two forces, then what I'll have, for tension to be 0, F1 has to be equal to F2. So that means Gmm upon 9L square. This I am equating this force with this force. This is 3L square, 9L square. This is 16L square. That I have to write only. Minus Gm square over L square must balance with G capital M small m divided by 16L square plus Gm square divided by L square. So this G and L square will cancel out from both sides of the equations. I'll cancel G and L square. Then I can cancel one small m also. Now what is left? It is m over 9 minus, this is small m, this equals to capital M over 16 plus small m. So that means 2m is m over 9 minus m over 16. So from here, if I take m common, it is 16 minus 9, 7 divided by so this is this value. I will have the small m as m divided by 2 into 7 divided by 9 into 16. This is 18 into 16. 18, 16 is this is 288. So this is 7m over 288. This is the value we obtained now. So when the mass is this only, then only there will be no tension in the rod. Now what is given is that this mass is k times m over 288. This is given. This is given in the question. So if I compare these two results, that is what is obtained and what is given, then clearly we can see that this k which is to be required, is to be found, must be 7. So comparing k is 7, and this is the answer to this question. Okay, so k must be 7. Okay, thank you.